Yeah, we are live. We are here
Yay.
tonight again with Kim. And yeah, so we had the first part of WDAC. Kim, that was 1 hour and 15 minutes, and it was like the evening just went away.
Yeah, it was good chatting.
It was
Because
really good.
that's largely what we did. We just
Yeah,
talked.
just talked. And I can say that this topic is very hot. Got a lot of views, got a lot of comments, and I mean, you obviously did a very good job on explaining VDAC, and I think that is one of the Defender endpoint security where most people don't know what it is and how to set it up and do stuff around it because yeah, it's just not there on any docs. Well, something is, but the real
there, there,
world stuff.
there's definitely docs. The problem with the docs is that a lot of this might be quite overwhelming from a technical point of view. And as we talked about last week, if you start doing your most challenging departments, typically the IT department first, this is gonna look like a very daunting task. And it doesn't necessarily have to. Is it gonna be work? Sure. But it can be very rewarding work from a security threat level point of view, and from time you gain in not having to put out fires every single time the next vulnerability hits.
Yeah.
So when done right, it does set you on a path where you can at least buy some peace of mind instead of trying to patch quicker and quicker and quicker at an incredibly rapid pace.
So this went out on Twitter yesterday, and Rue Campbell, a endpoint security architect, he actually wrote that AppAllowed listing should be alongside MFA as a no-brainer security fundamentals we all know about. So he agreed. This is something we need to get out to people to know about the feature. And yes, WDAC should be security fundamental.
Think I've seen that tweet, and I think indeed MFA protects your identities, and you probably need WDAC to protect your endpoints. There's obviously overlap between the two because typically the identities are abused to attack your endpoints and vice versa. But yeah, the combination is probably a worthwhile investment. And I think more people are convinced of the need for the MFA part than for the application control bit. But we're working on that, you and I, and a lot of people on Twitter are trying to advocate WDAC use.
Exactly. Also, Rudy Ooms from the Netherlands. He also had a lot of comments, and he also wrote a pretty technical blog post about WDAC, right?
A pretty extensive blog post.
Yeah, that's how Rudy is. He does very extensive work on his blogs. That's so cool.
Yeah, I quickly went through it. I didn't read all of it. I quickly went through it and then filed some comments this evening because we were talking about it.
So cool that you're here, Kim, to share your knowledge on this field. So really appreciate it. Thank you very much. So we should get going.
For promoting it.
Yes, thank you.
We're doing whatever we can to get people know more about WDAC.
Yes, we will. We will. Sure. So last time we were talking about the WDAC and why we should have it, and yeah, audit mode and all that stuff, and at least you gave me some points that really made me understand WDAC. I was like, yeah, what is it? And yeah, too much overhead on administering that piece of security, right? But really, my thought after the interview was like, okay, I need to make an audit going on in my own environment. So the thing about you mentioning this catalog file on XP to drivers to actually say, okay, this is a valid driver, you can install that, and having that catalog file to the application, that was really the point that made my
I,
puzzle.
I think that was a main part of what we indeed talked about last week. And it's one of these things we cover extensively. Because when people say WDAC is difficult, they typically mean that creating a policy for every individual application they have, that's something they consider to be extremely challenging. And they're at least in part right, and in a very large part. Building policies with WDAC, there's a WDAC wizard now that helps a bit. Jordan did a very good job on building that wizard. But just building policies and managing the policies is just a lot of work. And you have to start distributing those. Doing that through catalogs avoids you having to create a policy for every single application. You still need to have a catalog for all of your applications, but those catalogs are somewhat easier to build and somewhat easier to troubleshoot if you have them or not. So whenever we can, we try to make applications trusted without having to alter our policy. But to be able to do that, we need one single thing. We need a code signing certificate, because just like the catalogs for drivers, the catalogs for your applications will have to be signed by something that's trusted by your WDAC policy. But that's a mechanism we use extensively to make applications trusted.
Yeah, sounds so easy when you put it that way, Kim.
I wouldn't say it's easy, but it does allow you a lot of flexibility, and it does allow you a certain amount of automation in building those catalogs, which is slightly harder to do for policies, although we're trying to do that bit as well, building policies automatically for applications. Because the environments we're doing this in is what we call managed environments. I want 85 to 90% of your applications to be installed by some centralized systems management tool. If that's not your current setup, our advice is work on that first before you're going to try and do application control on top of that.
Yeah, and we were briefly discussing what kind of format of application automation that we should use. And I was suggesting maybe MSIX, which came in 2018, I believe. And you said it would be a brilliant idea because then we actually have a code signing certificate in our package.
Well, the interesting thing about MSIX and application control is MSIX is a packaged application, meaning it's a single file that is used for both installation and execution. Typically, if you look at traditional MSIs and MSIs that are a single file, you have a single MSI file for installation. Right? So you have to make that file trusted. Right? And then a number of files are written to disk, and you have to make all those files trusted. Right? The interesting thing about MSIX and application control is the only file you have to make trusted is the MSIX file itself. And through internal Windows mechanisms, very, very similar to what the security catalogs of driver does, all of the binaries within the MSIX will become trusted just because the MSIX that hosts them is trusted. And that takes a load of things off your hand. Making an MSIX trusted in Windows Defender Application Control, that means code signing it with one certificate that your environment trusts, and you're done. For both the installation of the MSIX and running all the code within it. So yes, MSIX and Windows Defender Application Control are pretty much a match made in heaven. John Vinsel did a very good job on getting that in from the get-go. I think it was functionality that was actually in, I believe, the original release of MSIX back in the days when nobody had heard about Windows Defender Application Control whatsoever. But yes, MSIXs are a very convenient way of making applications trusted. Okay. There's obviously the work to be done to convert your current applications into MSIX. But once that's done, there's not a whole lot of work for you left to do in Windows Defender Application Control.
Nope. And as you said, we need this centralized system, right? And we need these applications to be automated to actually install them from the centralized system we have. So why not go MSIX if you can? Obviously, there are some caveats or something that MSIX cannot do, but it's very limited though. It keeps getting better. And for those who don't know MSIX, it could sound like it is the successor of MSI, but actually it does not have anything to do with MSI, because MSI was a database format that put files and registry and services and all that on the device like a executable, just in a more robust way. Now MSIX is a successor of AppX, right? So the format we know from the Windows Store. So so that's what we're talking about here.
Yeah, it's a completely new format. It's the follow-on for AppX, AppV. It basically combines a whole number of previous installation technologies and packaging formats. The thing I typically like about MSIX, or that I typically call out, is what John Vinsel, one of the program managers, often says is our goal with MSIX is to make sure that you never regret having installed an application, which is very, very different from MSIs. You can install a bunch of MSIs and regret wholeheartedly that you ever installed them. MSIX being virtualized technology, once you remove it, all of it is gone. That's one of the other benefits of moving to MSIX. It's all virtualized software.
So what you're saying is that if we look into modern distribution technologies or onboarding technologies like Autopilot and Intune, there isn't really this bare metal installation, right? So we can't just do like config manager and press F12, get our new Windows on the device, our new clean Windows. So if we have this hardware lifecycle management on our devices and we have the software lifecycle management, if we have applications that has been virtualized like MSIX, it will keep our Windows from like being slower and slower and slower while we install applications and we remove them and we upgrade them, etc. So it actually goes hand in hand.
Yep.
Cool. So let's get on with part 2 here. So Kim, I want to ask you, these WDAC policies, where would we put them? We have policy engines like Intune, we have Configuration Manager, we have GPOs, we have even the local GPOs, not GPOs, but local policies. I've seen people that enabled, for example, audit mode on this area, and then the device just restarts. I mean, setting it from Intune, the device is just rebooting.
Yeah, it's one of those pain points, and probably one of those things that has turned quite a number of organizations and people away from Windows Defender Application Control. Unfortunately, historically, the initial implementation of Windows Defender Application Control almost always rebooted every single time you changed the policy. So that meant when you deployed an initial policy or when you deployed a modification to the policy. And from a security point of view, there's something to be said for that. Because obviously, application control is supposed to verify whether an application or a binary is allowed to launch, because that's basically what it is. We call it application control, but it looks at individual binaries that try to launch into memory. Obviously, processes that are already in memory, well, they're already there. There's no way for you to control them anymore. So that's what the reboot is about. We make sure that your modification is immediately enforced by rebooting you, because by rebooting you, I just basically kick everything out of memory again. And at the next reboot, I'll evaluate whether what was in memory was supposed to be there. So from a security point of view, it's a very logical thing to enforce a reboot every time you change policy.
Yeah.
From an end user perspective, though, that's totally unacceptable.
Yes.
There's no way that you can work in an environment and force a reboot every single time you change your mind on policy. And if you do, you're going to have incredibly heavy change management on you changing the policy at all. So Windows Defender Application Control later had a feature that said, okay, take this approach to not reboot and implement the policy with the risk that a certain process is already in memory that probably shouldn't be there according to the new policy, but we won't reboot. And then things started happening. The way Windows Defender Application Control was implemented in Intune was using a CSP that didn't know about this do not reboot thing. So even if you deploy the policy with do not reboot, the app locker CSP, because that's where this was in, would trigger a reboot anyway, because it didn't know about the changed functionality in WDAC that the reboot was no longer necessary. So to resolve all that, we needed a new CSP, being the app control CSP. I think Peter van der Water was the very first one to actually put out a blog post on, okay, so how do I use Intune to deploy a policy that does not reboot all of my machines within the next 10 minutes or so, and get me a bunch of angry emails and angry managers that
if the device came up again.
that come up and ask me what did I do to reboot half of the organization. I don't know whether I should I share the blog posts.
Yeah, definitely. Let's have a look at that.
Let's have a look. Okay. So you should see my screen now.
I do.
So the blog post is here. So Peter was the first one to deploy Microsoft Defender application policies without forcing a reboot. Interesting title for a blog post, because that indeed initially was one of the main issues we actually had. If you tried to deploy it using traditional Intune methods, any of the device configuration profiles, or anything to that extent. Anything other than, where is his custom OMA URI? Here he's still building the policy. Anything using something different than this particular OMA URI would actually reboot your devices. And that wasn't fun.
Nope.
Well, it was a bit fun, but not if it happened to you. It was fun for the other people around you that said, oh, look, somebody fell victim to it once more.
Yeah, it's cake day, as we say.
So this is one of the ways of deploying those policies, because that was what we're talking about, using custom OMA URIs. There's some slight challenges, though, with custom URIs, that their maximum size is limited to about 350 kilobytes.
What about if we had, like, I need this deployed all over the place. I need it on my servers, I need it on my clients, etc. What would be the preferred way then? Would that be
the method we use most often is doing it through Configuration Manager. So if you go to Assets and Compliance, you have the same endpoint protection node there. You can create Windows Defender application control policies here. As you can see, there's not one here because this is just a build lab that I'll explain later on. But in here, you just create your application control policy, give it just his initials. You specify whether you want to enforce or audit. You get to specify whether you want to reboot your devices. As you can see, by default, that's on. I highly recommend you turning it off. And then there's this interesting thing called inclusions, where you can actually create path rules that aren't path rules. This is, I believe we talked about that last week a bit, although I don't know whether that was while we were on recording or not. But this was Config Manager's implementation of building path rules before Windows Defender Application Control actually had path rules. So it would just scan all the files in this folder and create individual file rules for them. That's roughly what they did. The reason I'm showing that bit and I'm mentioning that bit is because that's one of the things we actively use and need in a Config Manager based implementation. Because as you can see, this does not give me the full control to the XML. And it doesn't grant me any option of including my code signing certificate that I just said we desperately need. Okay. So how do we get our code signing certificate in? The interesting bit is that this mechanism here with those pattern rules eventually creates files in this naming format. So files called code integrity whatever.xml. That's what they built with that interface we just saw.
Okay.
And in the end, all of these files, all of these XMLs are eventually merged into a merged policy enforced if you're in enforcement mode, or audit if you're in audit mode. So what we're doing is we're building our own code integrity files. We make sure they're stored in Windows CCM Device Guard. And by doing so, we actually get control over the full XML. And this allows us to add whatever XML we want inside the policy that Configuration Manager builds for us. So this is one of our tiny little trade secrets in making Configuration Manager actually workable for Windows Defender Application Control. without this, there's no way we could do what we've been doing at customers, especially this one. We need the corporate code signing certificate. There's some other things in there, like Microsoft creates a default set of deny rules, so we include those as well, using that same mechanism.
And what we see right now is actually a client, right? So we look into a client that has Config Manager agent installed on it, and this is in the library where we regularly go to logs and all that. That's inside that, right?
Yeah. Windows VCM device card, because that was the original name of application control. All of these files are actually created by Configuration Manager if you send out that policy. So they initially, well, assuming you have the MBAM agent installed, otherwise you'll be missing that folder. They actually create an XML that holds all the files they actually need to make the Config Manager client functional. They then merge all of the XMLs they find in this folder, and they then turn it into a binary WDAC policy. That's roughly what the backend process does, and we cheat by adding these 3 files. These 3 files are placed on this device by a package that we deploy in Config Manager. So we make sure that these files are there, so that they eventually get merged into your merged policy, audit, or enforced.
That was a good trick. So you're actually not taking these XML files and put them into Config Manager at the console where we just saw you configuring WDAC. No. This is actually just a small package that does a copy job, put these XML files in device guard, and then Config Manager will automatically merge these XML files?
Indeed.
Okay.
Indeed. That's what happens in the background.
Wow.
And that discovery gave us pretty much full control over what ends up in the eventual XML, the merged policy. That's the eventual end result of our policy. But by using this, we can actually add our own policies that we need into this. But as you can see in my environment, because we're looking at my workstation that I use as a daily driver, the only policies that are in there are something to have my code signing certificate trusted. We have something to have native images trusted. Native images are .NET technology. They're actually documented in the Windows Defender application control as they're probably going to be blocked, but that should be benign, meaning you can ignore those block messages. We actually create path rules for the folders containing them. One, because we had one single application for which we noticed that it wasn't benign. The application worked, but it threw an error pop-up every single time it launched the first time, which was somewhat annoying. And the second reason we created path rules is because the messages might be benign, but it's kind of annoying to have them fill up your logs and have your logs roll over quicker. And there could be some theoretical performance impact. The reason native images are created is they're compiled specifically for the hardware you're on. And there are DLL files in those paths that are specifically created for the hardware you're on to improve performance. Whether that impact is ever going to be noticeable is very, very questionable. But for all of these reasons, we actually create these native image path rules.
Yeah. Yeah, I mean, no one wants the event log to be filled with errors, right? We want there to be informational text, but not these red dots. It's like it irritates my eyes, and they shouldn't be there, right? But I mean, that's part of the Windows, because we can't have a Windows without something that
No,
goes wrong in the event log. That's how it is.
it is what
But
it is.
but if it fills up with errors, I believe that the CPU or the disk or whatever would be on working on something that it shouldn't be working on, right? So having the correct rules for a device, I think that's very important.
Yep. And then the third one we add is Microsoft's deny rules. If somebody finds a bypass for Windows Defender application control, then Microsoft actually creates a pre-compiled list of binaries that you should probably block. And we've actually submitted the Intune Management Extension agent ourselves. One of the older versions could actually be used as a bypass for Windows Defender application control. So the Microsoft deny rules now contain the Intune Management extensions up until a certain version, and all more recent versions no longer have the issue.
Cool.
And since the Intune Management extension agents upgrades automatically, the version we found it in was the version of August last year. So most people, if not everybody, should be running a more recent version than that.
Mm-hmm. That's very nice. So this little space you just showed us here, if I was going to do the same in Intune, is that even possible?
Is that even possible? Yes. Specifically in the new node that we talked about, the preview node, because you could basically just take this, the merge policy enforced XML. You could take that entire XML and just deploy it through that new Intune user interface. Right? Because they in their new interface give you complete access to any XML that contains a Windows Defender application control policy. Right? So that would be the way to do it if you do it through Intune.
So the trick here is that if I manage my devices using Intune, I'll just install the config manager and I push the policy to one device, and then I integrate all these XML files, and then I have the merge policy enforcement XML, and I can use that one.
Yeah,
that was a little hard set. Uh, uh, many
yep.
of the users that have Intune already maybe exist in a co-managed fashion or something like that. So it's very easy actually to use that trick and take that XML file and put to Intune. That's actually a very, very, very good trick, Kim.
But one of the reasons we still quite often use CM to deploy the policy is because CM actually creates this XML for its own binaries. Can you do that yourself and make the CM client trusted by yourself? Sure. But this does it automatically. If they upgrade the client, I don't have to create a new policy. They handle that for me. So that's why we often rely on CM to actually deploy the policy in environments that have CM.
Makes very good sense. Yeah, makes very, very good sense. And thank you for doing that, config manager team. That's extensive work.
Yeah, it's I don't know whether it was what was in their plan for us to use it this way, because as I explained, this is actually a side effect of them building path rules before path rules existed. That's what the mechanism was actually built for. But it does give us a very nice added benefit. And we've explained the config manager product team that is how we're using it, so that this functionality is pretty important to us. Because now that Windows Defender application control has path rules, they might consider removing that mechanism because they deem it no longer needed. But we heavily rely on it. And so we kind of need it to be there to customize the policy.
Exactly. So it's hardly imaginable, but some companies don't even have config manager or Intune to actually maintain their devices. I've seen lots of customers in Denmark are managing their devices just using AD. And in AD, we have GPOs, right? And I guess that we could set the WDAC policy in GPOs as well, but there might be some more work into it than using config manager or Intune.
Yeah, you could. Obviously, the GPO setting is there. There's a couple of challenges with doing this for GPOs. So, one, if you only have GPOs, that means you don't manage your software lifecycle much, right? Or you will have to use all MSIs deployed to group policies.
Yeah.
Right. But my guess is you don't have a centralized management solution at that point in time, which is going to make it hard for you to build the necessary policies or security catalogs to make everything trusted. Right. So that's one particular challenge. Right. Sorry,
Yeah.
I had to cough.
Yeah, that's fine. Yep.
The second challenge is that obviously group policies nowadays, well, to be able to receive group policies, you need line of sight to domain controllers. Which means that when you work from home, you have to have the VPN going, or you need a way to actually deploy those policies. I wouldn't feel very comfortable in an environment that didn't give me connectivity without the VPN. Because assume you do whatever inside the VPN client, or something changes in the VPN client, and the VPN client self-updates and stuff like that. There's no way for you to update your application control policy anymore, because the VPN won't come up, won't launch, won't work, and you don't have an alternate connectivity mechanism to actually update your Windows Defender application control policy so that the VPN client can work. So you're building a bit of a chicken and egg kind of problem that you probably want to avoid. So if you can either use CM with Cloud Management Gateway, so you have an alternative mechanism to remediate the situation, or use Intune, or preferably just use both, so that you always have an option to rectify your client agent and your application control policy should you have broken it. And so we don't have any strictly GPO-based implementations.
So what we are saying here, that is, we can actually rule out GPOs because having WDAC in a AD-only environment, that would make your heart very, very, your life very, very hard.
Yeah,
and the other thing,
I would go that route.
Yeah, no. So and the other thing is, yeah, exactly. When you have your device identity in a AD environment, that needs line of sight. And the other thing is a GPO, you set it and you forget it. You don't get any answers that this policy was actually applied to your device. So using config manager or Intune, where it actually says, hey, my policy is out there, and you have a response, and you can actually make compliance numbers out of these rules you put to the device, is actually a huge benefit. So, dear viewers, you should go using config manager or Intune for enforcing these kind of policies.
Yeah. Yep. Couldn't agree more.
So, the impact on the end user. We briefly talked about Intune and the unfortunate that it was rebooting a device. And I can see it from a security perspective, cleaning out all the processes that exist in the device running. So we need to reboot it to ensure that everything is cleaned out and we start fresh. That makes sense. But from a user experience, it doesn't.
Well,
And
yeah,
yeah.
the user experience for going to enforce obviously means that things that users could originally do won't be able to be done anymore. That's not a correct sentence, but originally a user could launch whatever executable he wanted. And obviously, the minute you go to enforcement mode, that's no longer going to be true. So there is going to be some end user impact. That's how we actually started, or how you and I started to communicate. And we need to talk about this more. If a user is being blocked, you have to communicate with that user, one, why that is, and two, you have them give them a way like, okay, it's fine that you're trying to block malicious things, but I, for one, know that what I'm trying to do now is not malicious. Right? And if the user is right about it not being malicious, and there's a true business need, then we need to modify our policy so the user can actually do whatever it is he's trying to do. So that's why I tweeted our dose notification mechanism that we've built and that I've blogged last week about, because we were doing this series, in communicate with the user. Look, this is what we do it for. Here's your options in reporting the executable that you still want to have executed, and we'll look at it. And if we agree with you that there's a justified business need, we'll modify our policy so that you can actually run this. So there's obviously that potential negative impact to the end user. There's also a very positive impact towards the end user. That means if you accidentally launch some malware, it won't run. Your system will be protected. And if it's not just you, but if it's one of your coworkers that accidentally runs malware that traverses the network and all of a sudden starts infecting everybody, you'll be protected as well. So there's a potential impact on things you try that we haven't foreseen, for which we don't have the policy. But there's also the peace of mind that an end user gets, that if he or a coworker launches something that they probably shouldn't have, right? They've been phished, and they didn't pay attention. All of these things just largely go away if application control is enforced on your device. So there is peace of mind for the end users as well, that they can no longer be the cause of the entire company being ransomwared because they accidentally launched a macro and they fell for some sort of phishing trick. Right. And there's peace of mind for us at the admins that the entire company is not ransomware because we did not deploy the software updates fast enough. And there's, again, peace of mind for the end user because they didn't install the updates quick enough. So yeah, there's no way to do application control without impacting the user's day-to-day work. Right? They'll eventually notice that you're blocking things, right? Just like with AppLocker. They'll notice that things that used to work now no longer work, right? And every once in a while, the dose notification we send out typically is sufficient to explain why we're doing this. Every once in a while, we need to have a talk with the user that's upset that what he used to be able to do is no longer possible. And we've had those talks with users and explain them why we do this, and what the risk of not doing it is. And then most people are pretty understanding, and then they every once in a while want the policy to be built quicker than what we typically can, but most people are pretty understanding.
We need to tell people that they are actually in a organization. They are on a work device. We have certain policies that need to be catered out. We need to make sure that nobody clicks the wrong things and infect the whole business, right? That's what we want to prohibit.
Yeah. And we need to explain that to be able to do that, we cannot have applications installed from just about anywhere.
No. So this is your insurance.
Yep.
For that. Yep. So we talked a little bit about this. I don't think it was part of our interview in the part 1, but it was one thing I remember that we needed to talk about, to tell people what this is. So we have this Apple a device, right? And we have this App Store. And Apple made it clear that you cannot install anything on the iOS device unless it's in the App Store. And before you can put stuff in the App Store, it has been somewhat scanned by Apple to make sure that no malware is in the app. So they have this ecosystem. So what did you explain about that on Windows? Can you repeat that, Kim?
I can. It's something my coworker Tom and I talked about, I think 6 or 7 years ago, when we initially started doing mobile device management projects. There was one thing that we thought was remarkable. One, maybe two, but the things we found remarkable was how low management was of doing mobile devices. The amount of settings management that you do on these mobile devices is nowhere near the amount of settings management that you do on a Windows device. So our initial question was, why is that? Why do we spend so much more time in managing settings on Windows than we do on mobile devices? And we quickly came to the conclusion that a lot of the things we do in settings management are security and compliance related. And we need that extended security and compliance because people can run software from just about anywhere. And that's when we said, instead of defining devices as mobile and non-mobile, because that's a very popular way of describing devices that we equally find odd, because defining a laptop as being non-mobile is somewhat a silly representation of what mobile is. But we started defining devices as open versus closed devices. And for us, an open device is a device that can run applications from anywhere. That means Windows, but that equally means jailbroken or rooted iOS or Android devices. Those are open devices. Closed devices are your standard iOS and Android devices that can only install applications from the store. A Windows device that can only install applications from the store. That's what Microsoft tried to do with Windows 10s. Or what we have now, a Windows device that has Windows Defender application control enforced. Those are closed devices. And the amount of management you have to do on open versus closed devices is massively different. The interesting thing, and that's what we talked about at the closing of week, but I don't think we were still recording, is that the interesting thing is if you ask people in an MDM project what you're supposed to do with rooted or jailbroken devices, so open mobile devices, the answer is always the same. They're not allowed to do anything. I don't want them on my network. I don't want them accessing data. I don't want them having access to my applications. Nothing. I want them reported. I want them blocked. I'm using conditional access to make sure they cannot do anything. I don't want them anywhere near my organization or my data. Now, the interesting thing is, if that's your approach to open devices, then why don't you have a similar approach for Windows devices? Because Windows devices can install applications from anywhere out of the box by design. So why don't you have app blocker or application control on Windows devices to achieve that same end result? And that's one of the things that has since puzzled Tom and I. Like, why did this double standard exist? And it's probably just history, but it's odd that people look at these different systems in such a different way.
Yeah, I'm just sitting and listening to it because it makes so much sense.
It's even better in person, because then I do this dramatic thing where I lift up my laptop and show it and say, like, give me a definition for this type of device where this is not a rooted or jailbroken device. Right? Give me a definition for rooted or jailbroken that doesn't fit this, and then I pick up my laptop. Yeah, with everything being remote, I cannot do my dramatic laptop exercise now. But
we'll have to get that another time. So I'll look forward to that in person, Kim. So it's a great speech, and it's definitely a good question why we allow that on Windows, even though we have standard users and we have administrators that we kind of get rid of the administrators and only allow standard users. We can actually still have application installing in the app data library, right? So for example, Google Chrome or Zoom meeting app, they go into app data, and that is just fine for them to install on the device, even though you're a standard user. So
yeah, that will no longer work in an application control environment, because that's typically incredibly annoying software.
And then you don't have to use these baselines to actually ask if the software is installed out there, because you know it's not.
No.
You didn't allow it.
Yeah, it eliminates a whole lot of the management need that you have to do, because you allow all pieces of software to run. And there's new push to, like, well, stop doing all that. But that's not how it works. We cannot stop doing everything we do in settings management without lowering the security bar substantially. So the only way to stop doing less settings management is to make sure that we have some compensating measures that make sure that our security bar at least stays at the same level, preferably is a bit higher up, to get us better protection. And once we achieve that, then I fully agree that there's probably a bunch of settings that are no longer as relevant once we have application control in place.
Very good. Very, very good. So we've looked at where do we set our policies. We can do it in Intune. We can do it in Config Manager. We have looked into what is the impact for the end user. We also have looked into how we can set up this WDAC. but we haven't talked about how we operate it really. Let's say I have had it in audit mode and now I have no longer these logs in my events. So I am pretty confident that I can enforce the WDAC policy now for a amount of devices in my environment. Now I get this new software that I need to be able to run on these devices, and that may just be, let's say, 10 devices out of all my total devices. Now, I have a rule inside my organization saying that if I need to spend money on centralizing these apps, it needs to go on at least 15 devices. Now, me having it installed on only 10 devices, I want to install this manually. So how would I approach that? How can I get this software green lighted or acceptable for WDAC to launch and install?
It obviously depends on the software. The majority of the software that just installs inside a program files folder, and that's it. You just scan that folder, create a catalog out of it, you sign the catalog, you distribute that catalog alongside with the application, and you're done. That's the most convenient way.
And the signing part here, is that using that WDAC visit that you told us about in the beginning of this part?
The WDAC what?
The WDAC wizard?
The wizard? No, not necessarily.
No.
Catalog files can be just signed in PowerShell.
Okay.
PowerShell has a PowerShell command called set authentico signature, and then you specify the name of the catalog file, your certificate, and preferably a timestamp server, and then the catalog is signed. Right?
Nice.
So signing catalogs isn't all that hard. And then you distribute the catalog alongside with the application, and you're done. So that shouldn't be all that hard. That being said, unless you have a ton of these applications, if 10 devices escape your WDAC enforced policy because they need a manual installed application that you cannot make trusted, by all means, don't invest your time in those 10 devices. WDAC, especially if you start initially, your initial goals should be, okay, how do I get the low-hanging fruit to be enforced? And if 10 devices escape me in that initial phase of the project, I couldn't care less. We'll get there eventually, or we won't. It doesn't matter. If you can get over 50% of your devices application control enforced, then you're making huge strides on a security level. If you achieve 80%, then you're doing amazing things from a security perspective. So what we're focusing on prior to ever focusing on that application that has to be installed on 10 devices is, so which applications go on all my devices? So the very first thing we do in every project is, very first question we'll ask is, what agents are you running? What's your anti-malware agent? What's your EDR agent? Do you have backup agents running? Do you have an agent running that centralizes your event log like Splunk? What other agents do you know about within your organization? And we'll make those trusted. And then we'll start looking at the logs, and we'll notice that most organizations have at least forgotten one or two agents that they run everywhere that they no longer think about, that they don't consider. So we'll do those. That's what we do. We do initially. that's the opening phase. The next thing we'll do, and I'll probably need to show that, because that's why I had that environment open. The next thing we do is we take applications and we've built a console extension that allows us to generate the security catalogs that we know from Windows drivers for a particular application. Right? This sets a whole bunch of things in motion that uploads the source files into an Azure environment, Azure storage, so we can collect it. And then we basically install the application within a virtual machine. We scan the disk for all files that have changed, and we build a security catalog out of that. And we do that in an automated fashion. So the very first thing we'll do is we'll take this console extension, we'll multi-select our applications, and we'll say, go.
Wow.
So we'll take all of your applications that you have, and we'll turn those into security catalogs. We'll then sign those catalogs, distribute the catalogs, and again, reduce a whole bunch of events by doing just that. Our build lab currently has, oh, it's not where it's at. So our build lab currently has a bunch of catalogs pre-created in this last run that we can distribute to have a bunch of applications trusted. So that's the second thing we'll do. And then the third thing we'll do in our approach is we'll have to centralize the logs. That's one of the challenging bits with a number of Windows 10 security features, like Windows Defender application control, but attack surface reduction rules have that same effect or that same challenge, as they generate a whole bunch of logs, but they generate them locally. So we need a mechanism to centralize them, because I'm not interested in looking at every individual device and go look in Events Viewer on what it actually reports. Right? So the next thing we do is something we've learned from our good friends at MSEndpoint Manager. They actually written a blog post on Log Analytics and App Locker better together. We're doing something similar, but for the Windows Defender application control logs. So we have the Windows Defender application control logs in Log Analytics. And then we start querying the Log Analytics logs to see, okay, so what exactly are now what we call the heavy hitters? Which types of files and processes still run on a large percentage of our devices? And then
So when we speak at Log Analytics now, a event log like application defender or defender for application control, I mean that can do extensive logging, right? So I know there is a limit before you need to pay money to put data into Log Analytics. So what is the average that you see on customers' cost of this?
It depends, as usual, and it largely depends because it's higher at the beginning of our project. Because obviously the interesting bit is we start enabling this and we start collecting logs quite early on in the process. Once we start distributing those security catalogs, the amount of events we get in each day just takes a nosedive. And a whole lot less events are reported on a day-by-day basis. Right? But on an initial deployment, the very first months, it's probably gonna be 5 to 10 cents per client per month. That's roughly the storage cost that we see initial. And then over the longer period, it depends on how quick your project moves along and how quickly we can reduce the amount of events that get generated. So it goes downhill from that, but that's roughly the cost that we've been seeing in a couple of environments where we do this.
It sounds affordable, so I guess that's okay.
It's not gonna break the bank, but there is a cost involved. It's not that we can do this within the free log analytics. If I'm not mistaken, the free log analytics doesn't allow you to save longer than 7 or 30 days, which is way too short for us anyway.
Yeah.
So there's definitely that bit that we have to account for. But this mechanism that Maurice, Jan, and Sandy built for AppLocker, we do something similar. It's a bit different than what they're doing because the way AppLocker logs and code integrity logs work are just different. But we put it in a custom log as well. We've had a question on the YouTube channel as well that that referred to hunting, because the other thing you could do, and I believe I have that open as well, is you could use advanced hunting to actually go look for things inside your hunting thing.
And this hunting here, that is Defender for Endpoint, right?
That is indeed Defender for Endpoint.
Yeah.
The challenging bit here, though, which is why we put it in our own custom log analytics channel. The challenging bit here is that they'll look at app control, executable, audited, or enforced action types. The challenging bit here is that this particular thing in advanced hunting is trying to combine your app locker and your app control logs in one single entity. That's challenging because of an unfortunate side effect if you enable managed installers in Windows Defender Application Control right now. I'll show you my app locker log. This is what my app locker log shows me on my device. It'll send a bunch of errors and warnings as to things that are being blocked. MSL S31 DLL in system 32 was preventing from running. I can tell you for a fact that all of these files are just running fine. None of them are being blocked. If I look at the following thing, it'll say, okay, this file was actually allowed to run because your app locker policy is in audit mode. So all of these are actually incorrect event log entries. The problem is they will show up in your advanced hunting, and they're very difficult to distinguish from app control entries. So what we're looking into doing, I think I open. No, I don't have that one open. So what we typically do is because we do not rely on app locker in an application control environment. So we typically just disable the log
Okay.
to make sure that these events don't show up. That way, I only end up with app control related events as opposed to being having a mix of app locker and app control events. So that will be one way of doing it for the person that asked the question in hunting. If you want to do it in hunting and you want to rely on managed installer, you'll probably have to disable the app locker executable log collection. Right. Or alternatively, do what we did, just build your own data set with the events that Code Integrity generates. And I still believe that for now, at least, that last option is probably preferred because it gives you more control.
Yeah. Very cool. So that was for Jonathan asking, and thanks for that on the YouTube channel. That was advanced hunting using Defender for Endpoint. And Defender for Endpoint, you can obviously have that if you have E3 or the Defender for Endpoint license or E5.
Yep. There's a separate security SKU that you can get, or by now, indeed, the plan 1 of Defender for Endpoint is included in E3 now, or the plan 2 in E5.
Yeah.
Spend that money.
Yeah. It's yeah. Defender for Endpoint is really, really great.
Yeah. Well, one of the other reasons, I can probably show that as well. Defender for Endpoint has threat analytics with the amount of threats that are actually being investigated or are actually tested upon in Defender for Endpoint. And this is what we referred to in our initial session when I said 95% of all of these threats are actually blocked by Windows Defender Application Control.
Wow. That's a big help.
95 out of the things that Microsoft actually sees as threats being abused in the wild. That's a pretty significant number.
But to be able to use this with your WDAC, you need to enable the intelligence something, right?
Yeah. You need to deploy the endpoint detection and response agent for Defender for Endpoint.
Yeah.
Okay. Yep.
All right. Very, very cool. So yes, that was the advanced hunting. Now, Jesse also asked a question. So WDAC, does it have any effect on the CPU performance? He noticed that when testing on his test machine, that CPU would get 100%. And yeah, you know as well as I do, when CPU is using 100%, it's not very easy to actually do any work. Is that any experience you have had once you go through a project like this?
No, it's not. It's not something we've seen before. There's a couple of things though that I could think of. One is the .NET native images that we already talked about. So you could create bad rules to make sure that these files can run. Although the performance impact of not having these should be relatively small, but that could potentially help. I don't know whether an extensive large policy would have a security impact, but as I explained, that's not something we do. We rely heavily on security catalogs. We equally rely heavily on managed installer. We haven't talked about managed installer, and our session is pretty close to being finished, so that'll be for the next session in 2 weeks, I believe.
Yes.
So we use that quite extensively as well to make applications trusted. So a smaller policy may or may not help in impacts on the CPU and on performance. But that being said, once a binary is being trusted, Windows Defender Application Control actually marks it as, okay, you don't have to do all this work again next time around. I've done this validation. Let it just run next time around. Okay. Because for a number of policies, we have to build the hash of the file. And if you're running a bunch of large files, then I can see that it might take a while to do that initial validation. But that should grow better in a matter of hours, a couple of days tops, if that's the problem. Because then most of your files will have the necessary tags to make sure they can run without having to be reevaluated.
Yeah. That's good to know. So very big thank you to Jonathan and Jesse for the asks. And please, if you sit and listen and you have a ask, then please comment on the show here. We'll have the question brought forward to Kim on the part 3 session, where we will go into the was it managed installer.
Managed installer.
Yes.
Managed installer, and probably we'll have to do the intelligent security gateway, which are two things that allow you to make application trusted without you doing a lot of the heavy lifting.
That sounds really promising. Kim, it has been an absolute pleasure. And again, time just went away. Once we get into tech mode, it's really nice to listen to your wise words here on WDAC, and yeah, it for sure looks like something that is doable without having the same knowledge as you. I'm very comfortable, at least, by starting something to look into WDAC, and I guess that many of the questions that people have on this particular area has been covered tonight, and yeah.
But for me, it's nice to have an audience. My wife and kids are slightly less impressed if I start talking with this Defender Application Control to them. So it's good to have an audience.
It's always good to have an audience, and yeah, I believe if you talk WDAC to kids, they sleep faster, and that's a good thing, right?
They're a bit old for me to talk them to sleep, but
great. Well, Kim, again, big thanks for doing this part 2. And I'm very much looking forward for part 3 in 14 days from now.
Likewise. It was good being here.
Yeah, thank you very much, and have a great night.